Okay, this is the last example problem of the section, and it's just like the last one, very similar. To start it, I'm going to start by taking the derivative. So for this one, I need the generalized power rule, which says that you can treat this just like a regular power, but I have to multiply by the derivative of the inside at the end. So that would be 2 times x squared minus 6 to the 2 minus 1 power, which is just 1. And then I need to multiply it by the derivative of the inside. So simplifying this out, I get 2 times x squared minus 6, and then times derivative of x squared is just 2x. Derivative of minus 6 is 0, so I just get 2x, or let's simplify this a bit. I get 4x times x squared minus 6. So it might be tempting right now to multiply this out, but actually don't, because we want to not have to do any factoring at the end. So if you remember, to find a critical point, we look to see if the function has any undefined derivatives, and it doesn't look like it. This is a continuous quadratic / polynomial thing. So I just set it equal to 0, and since I didn't multiply it out, this is actually pretty easy to solve for 0. Since this is multiplying right here, I can solve separately and do 4x equals 0 and x squared minus 6 equals 0. So 4x equals 0, that happens when x equals 0. And x squared minus 6, I would add 6 to the other side. X squared equals 6. Square rooting. Now this is a part where you have to be really, think very carefully here. So when I take a square root, it's possible there are 2 answers here, a positive square root 6 and a negative square root 6. So your calculator won't give you those 2 answers. It will just give you the positive one. So in your head, you need to always remember, if I'm taking a square root, is it possible there's a negative answer? And in this case, absolutely, right? Because negative square root 6, if I square that, that becomes a positive 6, and I get 6 minus 6 equals 0. So these are also possible solutions. So all of these are my critical points. Now I'm going to look for possible inflection points. So I had p prime of x from up above, which I'll write again, as 4x times x squared minus 6. So to get the second derivative, there's a couple different ways I could do this. One way is, actually we haven't learned yet, so there's just one way at the moment. And to do that, I'm going to multiply it out. 4x times x squared is 4x cubed, and then minus 6 times 4, so 6, 12, 24, get minus 24x. Okay, now I'm going to take the derivative of that. So 4 times 3, x to the 3 minus 1, 2, and then derivative of 24x is just a 24. Alright, now I'm going to clean that up. 4 times 3 is 12. I get 12x squared minus 24. Okay, and again, that's a polynomial, so there's no places where the derivative, or in this case, second derivative, is not defined. So I'll just set it equal to 0 and solve for the possible inflection points. So I'll add 24 to the other side, and I get 12x squared equals 24. Dividing by 12, I get x squared equals 2. And then again, notice I'm square rooting, so we have to think, is it possible to have a negative? And yes. So positive square root 2 and negative square root 2 are possibilities. So I've got quite a few more answers than I did last time. Now I'm going to use the second derivative test to find the relative min and max. So to do that, I take these values up here, my critical points, and I plug them into the second derivative. So p double prime of, let's do 0 first because that's easiest. So that gives me So actually that just gives me negative 24. And then I also need to do the square root of 6. This might be a little bit of mental math this time through. So I get 12 times the square root of 6 squared minus 24. Okay, square root of 6 squared is just 6. 12 times 6 I think is 72. 72 minus 24, however, that's going to be positive. So I don't really need to do more than that. I mean, I could like get out my calculator, figure out what 72 minus 24 is, but I know it's going to be positive. So I'll just stop there and work on the negative square root of 6. So actually, I bet this is going to be exactly the same. So 12 times the negative square root of 6 squared minus 24. Yeah, so negative square root 6, the negative when it gets squared will be positive, and then the square root of 6 squared is going to be 6. So I end up with exactly the same thing as before. I know it's positive. Whatever it is, it's positive. So I get two things, and then this takes some memory recall. If the second derivative is positive, that one is a relative min. Now, if we've got something that's, if we get a second derivative that's negative, that tells me that it's a relative max. Cool. Okay, let's keep going. So now I need to think about where it's increasing and decreasing. I've got quite a few numbers here this time. So 0 is one of my critical points. And then square root 6. So to figure out where to put square root 6 on this number line, I would probably do like a little bit of mental math. So the square root of 4 is 2. And then let's see what's next. The square root of 9 is 3. So this has got to be somewhere between 2 and 3. I'll just put it like right here. So you could just put it into a calculator like I did, not like I did, but if you wanted it to be a little easier, and then figure out exactly what it is. But I think it's somewhere between 2 and 3. So I put my dots between 2 and 3. Now I'll start points. I'll pick out some points. So I will need to do p prime of 3, p prime of 1, and I'm just picking points that are in the intervals here. P prime of -1 and p prime of -3. And then that will tell me about increasing and decreasing. And I'm plugging it into the first derivative. So if I plug in 3, I get 3 squared is 9. 9 minus 6 is 3. Then 3 times 4, I get something positive. And again, I'm just plugging it into this, derivative equation here. You're welcome to put it into a calculator. You don't have to do it in your head like I'm trying to do. So if I plug in 1, I get 1 squared minus 5, which is -5. And then times a positive, I get something negative. If I plug in -1, I think I'll get this. Oh, no, I won't. Okay, so -1 squared is 1, minus 6 is 5. Then times something negative, times something positive, I get something negative again. Not bad. I was right. Let me check this one more time. 1 minus 5. Yeah, okay. Oh, okay, I think I did do a little bit of mental math wrong. So -1 squared is 1. 1 minus 5. Okay, yeah, this should be positive. Now, if I plug in -3, -3 squared is 9. 9 minus 6 is 3. Then times something negative. It looks like I'll get a negative out here. So again, you could do all of that in your calculator. But I do think there's something nice about practicing mental math, because then I know I'll be better at it next time or when a test comes around. Now for the possible inflection points and working out concavity, I'll label the points, my possible inflection points. So square root of 2, I think, is between 1 and 2. So somewhere in there. And the way I know that is because 4, if I square root 1, I get 1. And if I square root 4, I get 2. So it's got to be between there somewhere. So I have to test a couple of points here. So I'll do the second derivative at 2 because that's in this interval over here. And then the second derivative at 0. And then also negative 2. Okay, so hopefully the mental math will be a little easier this time. I'm plugging it into the second derivative, which is over here. Okay, 2 squared is 4. 12 times 4 is 48. Minus 24, I get something positive. And then second derivative at 0, I would get, plug in 0, it looks like I'll just get something negative out. And plugging in negative 2 into the second derivative, negative 2 squared is still 4. 4 times 12 is 48. I still end up with something positive. Okay. Now I can label it on this little diagram I have here. I have 2, it was positive, 0 was negative, positive, and then negative 3 was negative, positive, negative, positive. Cool. So then I can write out my intervals of increasing and decreasing and concave up and concave down. Negative infinity to, okay, what was the value? So I need to figure out what my critical points are. It was negative square root 2. And, oh, and my bad, that's actually decreasing. Okay, for increasing started at negative square root 2 and went to 0. And then from square root 2 to infinity. And then it was decreasing in the other intervals, so negative infinity to, let's see, negative root 2. And then again from 0 to root 2. And then concave up, I used the second line. It was concave up from negative infinity to, let's see, what value was that? What was my possible inflection point? Negative square root 6. And then also from square root 6 to infinity. And then concave down in the middle between negative square root 6 and square root 6. Perfect. Okay. So does R of x have any relative extrema? And the answer was yes from our work above. You know, what we did up here in this little chunk over here. Now about the absolute max and absolute minimum. So this is a continuous function, so there's no beginning or end point on this at all. And I know, let's see, it's decreasing from negative infinity to negative square root 2. And then it decreases. Oh, do I have this backwards? I totally do. My bad. Let me say it. My words and my pen didn't match. So it starts by decreasing, then it increases, and then it decreases again, and then it increases. And I'm just using this little bit right here to draw that picture. Okay, so you know what? I think it might have an absolute max and it might have an absolute minimum. Oh, I mean, it might have an absolute minimum, but I'm not sure it's going to have an absolute maximum. So let's plug in our values because I think I found that we are going to have a minimum. So let's see which one's the highest. So let's see, where do we think there's 2 minimums here? So at square root 6 and negative square root 6. Okay, to figure out which one is actually the smallest value, I'm going to plug it into my original equation, which was a p, to figure out exactly, which one is the smallest. So if I plug in square root 6, I need my original equation, which was x squared minus 6 squared. X squared minus 6, all of it squared. So square root 6 goes here, and then a negative square root 6. So actually, it might end up being exactly the same. So square root 6 squared is a 6. 6 minus 6 is 0, so I just get 0. And then minus square root 6 squared is still just a 6. 6 minus 6 is 0. So what that tells me is that the way I've drawn this picture here, let's see, I'm trying to make it not so terrible, that these minimums here are on the x-axis. They have a height on the y-axis of 0. That's kind of cool that we know that and that they're the same height. So I think there is no absolute maximum, but I think there is an absolute min. There's actually two of them. One of them is at square root 6, 0. And the other one is at minus square root 6, 0. Kind of cool. Okay, if you have any questions, let me know on the discussion board.